Okay, let's see what we got here. And we got another easy, and it's been previously solved. Let's see if I can solve it again. Adjacent increasing subarrays detection 1. Given an array nums of n integers and an integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Two adjacent subarrays. Okay, so non-overlapping. Specifically, check if the two subarrays starting at indices a and b, where a goes k k length, strictly increasing. Strictly increasing, so it's not, so it can't be equal. Can't have adjacent values that are equal. And then nums b to b plus k. Adjacent means b equals a plus k. Okay. Return true if it's possible to find two such subarrays. Two such subarrays. Yeah, okay. So 3, so 2, 5, 7. This thing. Okay, is 3. Okay, 7, 8, 9, 2, 3, 4. And then k is 5. Here it's not possible. Okay. Interesting. Huh. It's not an extremely easy one. How would I do this? How would I do this? I could for each index. Yeah, I could have basically an array of booleans that is true if a certain index is the end index to a k length of strictly increasing values, and then use the prior values of that while iterating to see if the current index has a corresponding like true value. If the current spot is true and the spot k before that is true, then it works. Okay, so keep array of bools where array at I is true if if it is at end of k consecutive increasing values, and then make use of prior values in that array while iterating to verify to see if there's two sets or two streaks. Prior use of values in that. Okay, like, so for instance, if array at, say, k is 5, if array at 11 is true, and array at 6 is true, then return true. Okay, so let's say n is the length of nums. Let's say this, let's say possible is false times n, and then I'll set that to true if I see it work. I'll have a current streak. Yeah, and I have a current value, kind of previous. Maybe the current streak is actually 1, and the current value is, guess streak can just be 1. And then for okay, for every index in range n, let's say the value here is nums at this index. If the value, I need to handle this, keep on popping things and thoughts come into my head like k equals 1, needs to be a special handling for that. If the value here is greater than the value at nums at index minus 1, okay, this needs to have n minus 1, or it needs to start with 1. And this doesn't quite work out. If it's bigger than a strictly increasing, so the streak increments. Otherwise, the streak resets. And then I can say if the streak is greater than or equal to k, then possible at this index is true. And then last thing is handling if k is and then check if prior index in array, check for n condition. So if possible at index minus k is true, then return true. And then return false here. And then this thing doesn't quite work if it goes out of bounds. I think it can go to, so I think I can leverage the fact that negative indexing in Python is wraps around to the back of the array by doing n plus k. So then, like if k is 5 and you're at index 2, well, if k is at 5, then your streak can't actually, your streak can't actually go around that. Your streak can't actually be greater than k if your index like 2. Okay, that's fine then. And then I think the initial thing needs to be true if k is 1. And then possible at 0 is true. That's the only case when that's true. I think that works. Guess I don't need to have a val here. I can just use nums at index rather than nums at and then val. Didn't really reference val later on. So you increment the streak or you reset the streak. This should be inside the for loop. Whoops. the streak is greater than or equal to k, set to be true at this spot. Yeah, I think this should work. Huh. Slower than I expected. Okay. I guess the other thing I can do is, since I'm only keeping track of the indices where it's true, I don't need an array maybe. I could have a set of indices where it's possible. So let's say OK set. And OK set adds index 0. And then I guess I can do this check before actually. Where checking it is now just checking if the set has the index. If index minus k is an OK set. Otherwise do OK set dot add this index. So it saves memory from not having a full n size array. Oh my god, it got worse. Okay. Or not okay. What am I missing here? Each index in range. If nums is greater than index, increment it. I guess this thing could be inside here. This only works here, maybe. Is this correct? The edge case here is k equals 1. Might not work. So if you set your streak to 1, well, if it's 1, then technically it's always true, right? What am I doing? K is 1, just return true. So the thing is actually, I mean, assuming there's at least two elements to this array. The 1 less than, yeah, okay. K is 1 is always true because you can always have two separate one element parts, and the one element parts are strictly increasing. For each index, streak 1, and then go for every other index. Guess I can go range from 0 to n minus 1, indexing by index nums at index plus 1 compared to nums at index, maybe. I'm not sure if that's actually any faster. The streak is greater than 1, which it has to be. Okay, let's see this. I think this is still right. I don't think it's gone wrong with any of these changes. Oh my lord. If nums index is greater than nums index minus 1, streak increments. If the streak is greater than or equal to k, then Okay, well the set obviously doesn't work. I guess maybe hashing into the set is actually not that fast. So let's go ahead and go back to the OK. It's going to be false times n. I'll not call it OK set, I'll just call it OK. So then here, this is OK index minus k. Sure. Oh, this should be any faster. Oh my god. Fuck. Gets worse and worse. What the fuck? I mean, embedding this thing into here should make it faster since you have less comparisons that you always do during each loop. If num's index, square the num's index minus 1. The streak is greater than or equal to k. Turn true. Set the current spot to true. What is going on? What is going on? And I just don't understand how this is slower than the previous ones. Store the longest decreasing subarray starting and ending at index. Store the longest decreasing subarray. Starting and ending at an index. Longest decreasing subarray. So not increasing, but decreasing. So the longest decreasing subarray here is 1. Here's 0, or 1, 1, 1, 1, 1, 2, 1, 1, 2, 3. Store the longest decreasing subarray starting and ending at an index. The longest decreasing one starting and the longest decreasing one ending at this index. Longest decreasing one starting at this index is 1. The longest one ending at this index is 1. This one starting would be 1, ending is 1, 1, 1. Oh, I'm looking at the wrong one. How does that help you? So here it's longest decreasing one starting here is 1, ending here is, or starting here is 2, ending here is 1. Oh. Increasing. Strictly increasing. Must be Hmm. Greater than or equal to k. One, two, three. Longest decreasing subarray starting and ending at an index. What does that matter? The longest starting at 4 is 3 long. The longest decreasing at 4 is 1. But even storing that information, I'm not sure how that's any faster than storing this information. Okay, I'm done. Sometimes you beat the curve and sometimes you help others beat the curve. Okay, summary. So, keep an array of booleans where array I is true if the k values ending at array at nums at I are strictly increasing. Iterate over the indices of nums, updating the keeping track of the current streak of increasing values. Update the array I appropriately. I.e. if the streak is greater than or equal to k, then this array I is equal to true. And if both array I and array at I minus k are true, then it's found it has found the two adjacent increasing subarrays. Return false if loop does not return true, or short circuit return true. Okay, time complexity is going to be O of n to iterate over every element or every index slash element of nums in the worst case. And then space complexity is O of n for the fixed array of booleans, which has the same length as nums array. Alternatively, can use a set rather than a list of booleans, which in theory would I guess still be O of n. I guess O of n but in practice would or should be smaller, should be considerably smaller. Although computationally it might be slower to add check stuff instead of an indexed array. All right,